Hello, Matthews Gatos here. In this video, we're going to review derivatives and antiderivatives, and I have 4 questions to do that. So in my first question here, I have the natural log of 1 plus x squared all square rooted. So I'm going to start by finding the derivative of that. So y prime equals, so the derivative of ln of any argument is 1 over the argument, and then multiplied by the derivative of the argument. So that would be 1/2, 1 plus x squared, decrease my power by 1, and then chain rule, multiply by the derivative of the inside. So putting this together here, I have half of 2, that's just x. So I would have x over the square root of 1 plus x squared, and then this as a negative goes into the denominator, which is 1 plus x squared. So those two roots are identical, so that means that y prime would be x over x squared plus 1. So that means the derivative of ln root 1 plus x squared is just x over x squared plus 1. So remember that antiderivatives are just the reverse process of derivatives. So that would mean that the integral of x over x squared plus x dx, again, these are just the bookends, the start and the end of the integration. This is the integrand, and the x just tells us we're doing it with respect to x. So that would mean the integral of x over x squared plus 1 dx is equal to the natural log of 1 plus x squared, and then we add on our constant of integration. So it would be plus c. Okay, in my next example, I have a product, 3x squared e to the negative x squared. So what I'm going to do to take the derivative is I'm going to use my product rule. So that's 1 d2 plus 2 d1. So 1 3x squared times d2 e to the negative x squared, and then the derivative of the exponent, negative 2x, plus 2 e to the negative x squared, d1, derivative of 3x squared, is 6x. So let's tidy that up a little bit. So I've got negative 2x times 3x squared, negative 6x cubed, multiplied by e to the negative x squared, plus, we'll just write the 6x up front. Okay, now at this point here I can either expand or factor. Well, there's really not much to expand, but I do see some greatest common factor there. So I see a negative 6 and an x and an e to the negative x squared. So factoring that out, negative 6 times divided by negative 6 is 1. X cubed divided by x is x squared. 6x divided by negative 6x is negative 1. And e to the negative x squared divided by e to the negative x squared is 1. So finishing this off, I'm going to have negative 6x in the numerator. I'll factor the difference of squares and then place it over e to the x squared, with the exponent being positive now that it's in the denominator. So that means the derivative of 3x squared e to the negative x squared is equal to negative 6x, x minus 1, x plus 1, all over e to the x squared. So because integrals or antiderivatives are the reverse of derivatives, the reverse process, then I would know that the integral of negative 6x, x minus 1, x plus 1 over e to the x squared dx would equal to 3x squared e to the negative x squared plus my constant of integration, plus c. Okay, next example, number 3. So I have e to the 4x minus 1 all to the 1/2. So like a square root. So to do that, I'm going to use the power rule. So I'll bring the half down. Oh, that's minus 1 on the outside, like that. Decrease my power by 1, and then multiply by the derivative of the inside. So the derivative of e to the 4x is e to the 4x. But because my exponent's not just x, I do the derivative of my exponent, which would be 4. Okay, so half of 4 is 2. So I can just write the 2 and the e to the 4x up front. And then e to the 4x minus 1 to the 1/2, or just square root, would be on the bottom. So that means that the derivative of e to the 4x minus 1 to the 1/2 is 2e to the 4x all over the square root of e to the 4x minus 1. So again, because derivatives and antiderivatives are the reverse of each other, I would know that the integral of this function dx is equal to e to the 4x minus 1 to the 1/2 plus c. Okay, one more example that we'll do. I've got y equals 4 to the x cubed plus 2. So let's do the derivative of that. So the derivative of 4 to the x cubed plus 2 is the exponent itself times the natural log of the base. And since it's not just 4 to the x, I also need to use chain rule and do the derivative of the exponent, which would be 3x squared. So multiplying these together, let's just put our numbers up front, which is 3 and ln 4, that's just a number, times x exponent 4 multiplied by 4 to the x cubed plus 2. So that means the derivative of 4 to the x cubed plus 2 is 3 ln 4, and we can actually simplify this if we wanted to. So what this would be is bring the 3 up. Actually, let me do this over here. Let's bring the 3 up as an exponent, and that would be ln of 4 cubed x squared times 4 to the x cubed plus 2. So let me do that over here. So 4 cubed would just be 64. So this would be ln of 64, ln 64, x squared, 4 to the x cubed plus 2. So again, since integrals or antiderivatives are the reverse of derivatives, we will say that the integral of this function dx is equal to the original function plus c. So plus the constant of integration. So I hope that this video helped, and in the next video we will be talking about substitution rule. So if you liked the video, give it a thumbs up and subscribe so you get notifications of any future videos I make.